Okay, so now that we've finished all of section 1.1 and understand all about the angles and the different ways to measure them and how to draw angles, now, believe it or not, we're going to skip to chapter 3. There's 2 sections in chapter 3 that relate directly to angles. So I want to keep with this concept and keep us going with angles. And what we're going to do today is section 3.1. Now, everybody look at me and listen. Degrees is a way to measure an angle. It's a unit. Let's think about things that we measure. The most common thing we measure in real life is our height. Every time you take your child or you go to the doctor, one of the first things they do is measure your height. In America, when we talk about our height, we talk about it in feet. So everybody, I'm 5 feet tall. We all understand that. But we know feet can be converted into inches because we know every 12 inches make a foot. So if I'm 5 feet tall, I'm also 60 inches. Let me ask you a question. Does it matter if I say I'm 5 feet or if I'm 60 inches? Are those 2 different units? Well, they're 2 different units, but they're measuring the same thing, my height. So there are 2 ways to represent my height. In real life, in the United States, we measure degrees in Fahrenheit. But we all know there's another way to measure degrees, and there's also Celsius. Okay, just because part of the world uses Celsius and we use degrees, Fahrenheit for degrees, doesn't make a difference. They do the same job. Okay? So I want you to think about in real life, we have different units that do the same job. We measure something in pounds. They may measure something in grams. They do the same job. So we know we have an English unit of measuring and we have a metric unit of measuring. Well, the same is true with angles. The most common way we measure angles is degrees because, again, it goes back to this lovely tool, the protractor that you first learned to use in elementary and high school. But degrees is not the only way to measure an angle, and that's what Chapter 3 is about. Chapter 3 says, hey, wait a minute. If you can measure an angle in degrees, there's got to be another different unit that we can use. And our new unit of measurement is called radian measure. What's your new unit? Radians. The first thing I'm going to say is there's no symbol for radians. I know every time we write degrees, we put the little circle. We do not have a symbol for radian measure, and this is the reason why. Radian measure is an angle measurement that's an actual number. Now let me say that again. Radian measure is an angle measurement that's an actual number. Now I know what you're thinking. You're saying, well, 90 degrees is a number. No, it's not. If you look at a number line, do you ever put on a number line the number 90 degrees? No, you do not. Just like you never put on a number line a percentage. If you write out a number line, there's no 90% on a number line. The only kind of numbers on a number line are whole numbers, fractions, decimals, mixed numbers, positive numbers, negative numbers, rational numbers, irrational numbers. Percentages are not numbers. You have learned since elementary school, if I said 90%, what does that mean? It means either A, 90 out of 100, which is a fraction, that's on the number line, or it's decimal point 90, a decimal, which is on a number line. So if you've heard since elementary school, anytime I give you a percentage, you either change it to a fraction or a decimal because those are numbers on the number line, and then you can use it for a calculation. Make sense? Think about when you do sales tax. If there's 8% sales tax on your bill of $100, you convert 8% either into a fraction or a decimal and then times it by that $100 to find out what your tax is on your bill. Correct? So percentage is not a number. Therefore, degrees is not a number. When you talk about 90 degrees, you're automatically talking about 90 out of 360, which is a fraction. So when we talk about degrees, that is not a number measurement for degrees. So in math, we need a number measurement for an angle to do calculations with, as we're going to see later in the next section. So that's where radian measure comes from. And this is where radian measure's definition comes from. If I have a picture here of the circle, And if you look, I have the angle in the center, which you called in geometry the central angle, marked as theta, because remember, theta is the symbol we're going to use if we don't know the actual measurement. And if you remember, from here to here, from the center of the circle to the edge of the circle is called the radius, which is abbreviated with the letter R. And from here to here, let me highlight it, is the length of part of the whole circle, which is called an arc. Remember, circles do not have sides, so that part is called an arc. And they use the letter S to represent that length of that arc. The rule is the measure of this angle is the length of the arc divided by the length of the radius. So suppose you had a ruler and you measured this radius to be, say, 6 inches. And then you had a ruler and you measured the length of this arc, say, to be 12 inches. The measure of this angle theta would be the length of the arc, 12 inches, divided by the length of the radius, 6 inches. Well, what happens when you divide 12 by 6? You get 2. But what happens when you divide inches by inches? Well, that's like dividing the letter x times the letter divided by the letter x. You know from arithmetic, if you divide the same number, 3 divided by 3, it cancels out, it makes 1. You learned in algebra, if you divide x by x, it cancels out, it makes 1. So when we divide inches by inches, that cancels out. So it says here the angle measurement is 2. It's not inches. Angles are not measured in inches. Angles are measured either in degrees or this new measurement, radians. Do you see a degree symbol anywhere in this calculation? No, you do not. So this angle measurement is in radian measure. When an angle is an actual number, 2 is an actual number. You know on the number line where 2 is. That is radian measure. And that's what we're going to talk about today. Now, you're going to say, where did this come from, this formula? Let me show you. It is important in a higher math class that we just don't give you rules, that you understand where they came from. All right, so here I started with a circle from geometry. And if you all know, when we take a circle and we draw a line straight through the middle of the circle through the center, what's that called? Good. This is your diameter. So AB is your diameter. But we know every diameter can be broken into 2 parts called the radii, plural for radius. So you have a radii here, AO, and you have a radii here, OB. And what do you know about all the radii in a circle? Good. They're all the same length. They're all equal. I don't actually have a number for this, so I'm going to call this radii radius R. I'm going to call this radius R. So the length of each radius is R. Now, we know if we go all the way around the circle, if we want to measure the whole arc, because remember, a circle doesn't have sides. We want to measure the whole arc. Going around a circle is called the what? Circumference. Remember that? All right, let's go, geometry gurus. What's the formula for circumference of a circle? You should remember it is 2 pi r. It's 2 times pi times the radius. Okay? Now, I don't want to know all the way around the circle. I want to know a piece of the circle, an arc of the circle. And I'm going to pick this arc right here, from here to here, from A to B. I want to know the length from here all the way from here. So I call that semicircle AOB, or arc AOB. I want to know its length. Well, we all know this. This is going from A to B, is going halfway around the whole circle. So to find the length of A to B would be half of the circumference. Do you agree with that? So I'm going to take the length would be half of our circumference, which is 2 pi r. Well, what happens when you take half of 2? Very good. It becomes 1. So we know the length from here to here as a number is pi r. Whatever the radius is, whatever number the radius is, if we multiply it to pi, which is approximately 3.14, we'd get a number which is the length. The rule says the measured angle AOB. This is angle AOB from here to here. It's that angle in the center. Everybody look at it closely. What kind of angle is it from chapter 1 that we talked about? Well, here's the initial ray. Let me outline it. and here's the terminal ray. Well, that happens to be a straight angle. And we all know a straight angle is how many degrees? Good, it's 180. So from geometry, we know that that angle is 180 degrees. But degrees is not a number. So I'm trying to find the number measurement. So the measurement of that angle, AOB, according to this formula, would be the length of the arc divided by the length of the radius. Well, the length of the arc you just said here is pi r. You said from here to here is pi times the radius. The length of the radius is we're calling r. So what is going to happen to these r's, guys? Very good, they're going to cancel out. So we know the measure of angle AOB is pi. Again, don't you agree with me? Pi is a number. What do we always say? Pi is approximately 3.14, right? An angle measurement as a number is in radians. There is no degree symbol here because it's radians. So now we know that this angle, therefore, the measured angle AOB is pi radians. And we know that pi radians is exactly how many degrees? We know from here to here is how many degrees again? 180 degrees. We just came up with a rule. Any angle that is 180 degrees is in radian measure the number pi, 3.14. That is a straight rule. We can use this rule to make a conversion. You know when we convert inches to feet and feet to inches? We're going to do the same thing here. We're going to convert radians to degrees and degrees to radians. So from this statement we just proved, we just geometrically proved that any straight angle, which we know is 180 degrees, is always going to be this many radians. Why is this radian measure? Because it's a number. We can now come up with a rule. We're now going to convert this back and forth. Okay? So before we continue, let's just recap. We're talking about measuring the angle in a new unit called what? Radians. Radian measure is a number measurement. If the angle has a number on it and there's no degree symbol, it's in radian measure. There's no symbol for radians, it's just radian. The definition came from taking the length of the arc and dividing by the radius. If you take the length of the arc and divide by the radius, that will always give you the angle measurement in radian measure. And we just proved for every 180 degrees, that would be 3.14 radians, or pi radians. Now I'm going to use that fact to come up with some conversions. All right. So let me just erase this for a minute and show you what we're talking about. We know pi radians is 180 degrees. So guys, what happens if I wanted to know what 1 degree was? If I want to change that to the number 1, how can I change 180 degrees just to 1 degree? Well, mathematically, the way to change that to 1 is divided by itself, right? But whatever I do to the right, I got to do to the left. Now you have a rule. Pi over 180 degrees will equal 1 degree. Every degree is this many radians. Every degree is this many radians. So if I want to change degrees to radians, that's my conversion. Just the opposite. If I write that same rule, from our diagram we learned every 180 degrees is pi radians. Suppose I wanted to know what 1 radian was. Well, the only way to change pi into the number 1 is to divide it by itself. What I do to the left, I do to the right. That would give me 1, I'm going to write the word radian here. 1 radian is 180 degrees over pi. That's going to be your conversion. 1 radian is that many degrees. You have to memorize these two conversions because throughout this semester, we're going to have angles in both units, and you're going to have to convert. Just like you know, to change 5 feet to inches, you multiply by 12. If I had 60 inches to make it feet, I would divide by 12. All right, so let's go to our notes, and let's go to example 1B. 1B says, change to radian measure. Right now, we know that's degrees because it has a degree symbol. Okay? If I want to change degrees into radians, we're going to use this conversion. 1 degree is this many radians. I have 300 degrees. So what are we going to do with that? Well, think about it. If, I don't know, 1 pair of jeans costs $50, how much would 4 pairs of jeans cost? Wouldn't you multiply 4 times 50? So if 1 degree equals this many radians, pi over 180, then to change 300 degrees into radians, that's what we're going to do. We're going to multiply by pi over 180. That's all. Now, I'm going to make 300 degrees, negative 300 degrees a fraction by putting it over 1 because I know to multiply fractions, it's top times top and bottom times bottom. Now, what I want you to notice is there's a degree symbol in the numerator and a degree symbol in the denominator. What's going to happen when there's a degree symbol in the numerator and a degree symbol in the denominator? They're going to cancel out. So the degrees are gone. All we have now is negative 300 pi over 180. That's not an acceptable answer because you have to reduce the fraction. So 300 and 180 both end in a 0, so I'll divide them by 10. So that gives me 30 over 18. 30 over 18 are both multiples of 6. So how many 6s go into 30? That would be 5, and it's negative 5. How many 6s go into 18? That would be 3. And then there's the pi symbol. This angle here is in radian measures. This is an actual number. Now you're going to say, do I need to take the pi and replace it with 3.14? Read the directions. The directions on this one say leave answer in terms of pi, or give me the exact angle measurement in radians. That means you leave it as is. 99% of the time, you know you're in radian measurement because you see the pi symbol. This is a number. That's all. Let's do 1D. I have 1,800 degrees, and I want to change it to radians. So the conversion is, to change this to radians, we multiply by pi over 180 degrees. What you'll notice is the degree symbol in the numerator and the degree symbol in the denominator will cancel out. They're dividing. What you're left with is 1,800 pi over 180. And then it's a fraction. We're going to reduce. They each end in 1 0, so if I divide that by 10, I get 180 over 18. Well, 180 divided by 18 is just 10 pi. That's your angle measurement in radians. There's no symbol with it. It's understood with the pi. It's in radians. If the answer says leave angle in terms of pi, you leave the pi symbol alone. Everybody good with that? Cool. So the moral of the story is you have to memorize this conversion. Now, next part says, in part 2, says to change degrees into radians, but now it says to round. When it says to round, we're obviously going to use our calculators. Okay, so again, I have 39 degrees. They want me to change that to radians. So the rule is the conversion. To change degrees into radians, what do we multiply by? That is correct. Pi over 180 degrees. What's going to happen to the degree symbols? They're going to cancel out. That's going to leave me 39 pi over 180. Now on this one in the assignment, it does not say to leave in terms of pi. So I'm just going to go back and read to make sure we round to the appropriate place value. It says round answer to the nearest thousandth. If it says to round, we're going to need our calculator. So to get out your calculator, what we want the calculator to do is do 39 times pi times divided by 180. Now here's the catch. You can't just use pi as 3.14 anymore. As you all know, pi is an irrational number. That means it's a decimal, that's non-terminating, doesn't end, and it's non-repeating, doesn't have a pattern. Every single calculator has a pi button. Again, on the TI-30X2S, your pi button is in the first column, the fourth row. There is a pi button. On the TI-36 Pro, it is also in the first column, fourth row. So you have to use the actual pi button. Do not just round it on your own. So now you go on your calculator and you type exactly what it says. 36 times, get your pi button up there, pi, divided by 180. Do not use a fraction bar. You use the division symbol. Divide. You hit equals, and you get out this lovely irrational number, this decimal. So I'm going to write exactly what we get out. And again, most of y'all do a great job using your calculator. It's the rounding. It says to round to the nearest thousand. Thousands is 3 positions to the right of the decimal point. I have a 0 in there, but there's a 6 behind it, so that should round up for 1. So in radian measure, this is 681 thousandths. Do not put a degree symbol. This is radian measure, no symbol. Okay, let's look at 2C. 2C wants me to take this angle measurement, 122 degrees, 37 minutes, and change it to radians. Here's the problem. This is not just degrees, it's also minutes. So there's an extra step. Remember, DMS, degrees, minutes, seconds, is not a number to work with. Minutes and seconds is not a number. It's part of something else. Before you can do the conversion, you first have to change DMS always to D form, decimal degrees. So we just learned how to do that in the previous videos. So we're going to type in 122, go get my degree symbol. We're going to type in 37, go get my minute symbol. So remember, we type it in where we have degrees and minutes. We hit enter, and it spits out a decimal. Do not round that decimal. You write the whole thing. This angle measurement in decimal degrees is 122.61666667. Do not round that. You don't round to the very end. That is the actual angle measurement in decimal degrees. So I'm putting the degree symbol. Now that this is a number, we can make the conversion. We can multiply this number times pi over 180. So we're going to take that whole decimal degrees, multiply it, hit times pi, divided by 180. And we should get out this decimal. Everybody see that? We will get out the decimal, and I'm going to write the whole thing, 2.140064551. So guys and gals, first thing, when you have an angle in degrees, minutes, seconds, DMS form, to do any calculation with it, it has to be changed into a number. That's what DD is, decimal degrees. So we change it into a decimal. Point 2, do not round this. We're needing it for a calculation, so we use the whole decimal degrees. We multiply that by pi over 180 because we're changing it into radians. Here we go. Now that we did our conversion, now we can round. I'm looking for the nearest thousand. A 0 is in the thousand spot. Behind that is another 0, so this in radian measure is 2 and 140 thousandths. No symbol because it's radians. Radians is a number for an angle. Okay, now we're going to have fun and go backwards. If I give it to you in degrees, I could change it into a number radians. Now let's go backwards. I'm going to give it to you in radians. We're going to change it to degrees. Now throughout this course, it's going to be very obvious when it's in radians. Most of the times when it's in radian measure, it has a pi symbol in it. Any angle with a pi symbol is in radian measure. You have no idea what 3 pi over 4 looks like. It is important in this course you do know what the angles look like. So it makes sense for us to change radians into degrees. How are we going to do that? We're going to do it by this conversion. 1 radian is 180 degrees over pi. It's the reciprocal. So we're going to take this 3 pi over 4 radians, and we're going to multiply it by 180 degrees over pi. Now, guys, this should make sense. Pi is in the numerator here. Well, if we're trying to change to degrees, we're trying to get rid of pi. So if pi is in the numerator here, it's got to cancel with pi in the denominator here. So the pi's are going to cancel, and we'll be left with 3 times 180 degrees over 4. So 3 times 180 degrees is 540 degrees. We're going to divide that by 4. And we're going to get 135 degrees. What I want you to note is when we change radians into degrees, we put the degree symbol. Because look, the pi's canceled out. There's a degree symbol in the numerator, but there's not a degree symbol in the denominator here. That degree symbol stays. Okay? So that's in degrees. If you don't write 135 and you don't put the degree symbol, I mark you wrong because that looks like to me 135 radians. Something totally different. So if the answer is in degrees, put the degree symbol. All right, let's change 3 pi, that angle measurement, into degrees. So the conversion is multiply by 180 degrees over pi. If you need to write this as a fraction, put it over 1. What's going to happen to the pi symbols? They're going to cancel out. That's just 3 times 180 degrees, which is 540 degrees. And you can visualize that. If I said draw me an angle that's 3 pi over 4, you would have to change it to degrees. Then you could draw that for me. You all know how to draw now a 135 degree angle. If I said draw me an angle that's 3 pi, that means nothing to you. If I change it to degrees, you know how to draw me an angle that's 540 degrees. You make a complete rotation and some more. Now, let's go to the last set, 4A and C. 4A, that's an angle measurement. It's the number 2. Do you see a degree symbol with it? Heck no. So that means that angle's in radian measure. Even though it has no pi, it's a number. An angle measurement that's an actual number is in radian measure. So if this is radians, the rule is to change it to degrees. We multiply by 180 degrees over pi. Now you're going to say to me, well, look, there's no pi to cancel with. You are correct. So if you read the directions, here they're going to ask you to round because you're going to need your calculator. Because this pi has no pi to cancel with, we're going to need our calculator to do the calculation. So let's just look at my notes quickly and let's see where I wanted you to round this to. And if I look quickly, I believe it says to round it to, oh, let's see, convert to the nearest minute. We're going to round this to the nearest minute. So the first thing first, I'm changing 2 radians into degrees. So I do my conversion 180 over pi. I got to just type in the calculator exactly what this says. This says 2 times 180 degrees divided by pi. That's exactly what I'm going to type in the calculator. So let's do that. 2 times 180 divided by the symbol pi. That's what you should be typing in. See it? Good. Hit equals, and it gives you out a decimal. 114.591559. Everybody look at me. You started with 2 radians. See the degree symbol here? It had nothing to cancel with, so this is degrees. What kind of degrees is this? Degrees that has a decimal point is called DD. That's decimal degrees. This doesn't want decimal degrees. It wants DMS, the nearest minute. So you already learned in a previous video, how do you change DD to DMS? You keep this whole thing in your screen. Do not round it yet. If you round it now, you won't have the correct minutes and seconds. You keep this whole decimal degrees in your screen, and then you go to your button and get out your DMS button. So I'm going to go get my DMS button, hit enter. So if you look, if you put the whole thing with DMS, and I'll hit it, and here's what I'm going to get out. I'm going to get out 114 degrees, 35 minutes, and 30 seconds. Did everybody get that? Good. Now, it said round to the nearest minute. All right, people. We're going to keep the 114 degrees. There's 35 minutes and there's 30 seconds. So to round minutes, we're going to have to look at seconds. Now, this is 30 seconds out of how many? Very good, 60. 30 over 60 is a half, which is a decimal point is 0.5, right? So don't you agree that's going to round up? So think about this. When we're rounding nearest minutes, we have to look at seconds. 30 or higher seconds rounds up the minute. There we go. All right, let's try one more. Let's do the 4C. So this is radians because it's a number. I know it's an ugly number, but it's a number. We're going to convert it to degrees. The conversion is 180 degrees divided by pi. There is no pi symbol to cancel. That's why we're going to need our calculator. So we're going to type exactly as we read this. I'm going to type little negative 3.47189 times 180 divided by the pi symbol. We're going to get out a big, ugly decimal. We're going to write the whole thing. When we multiply that out, we get a negative 198 decimal point 9246439. Everybody look. This was radians. You did this conversion that has a degree symbol, so there's a degree symbol there. That is what form of degrees? Very good. That's decimal degrees. It has a decimal point. Do they want decimal degrees? No. They want degrees, minutes, seconds. So now you've got to go in your calculator and get your DMS button. So you keep this whole decimal on the screen. You go get your DMS button and you hit equals, and it spits out negative 198 degrees, 55 minutes, 29 seconds. Now we can round. We're rounding minutes. If we have 55 minutes, we got to look at seconds. We have 29 seconds. Would 29 seconds round it up? No. 29 seconds is less than a half, right? There's only 60 seconds in a minute. 30 would be halfway. This is less than a half, so this is going to stay negative 198 degrees, 55 minutes. Okay, this is important. Degrees is not going anywhere, DMS is not going anywhere, dB is not going anywhere, and radian measure is not going anywhere. You need to understand an angle can be measured in both units. You now have to know how to convert between both units. This should become second nature, multiplying by pi over 180 or 180 degrees over pi to do the conversion. You need to know how to use your calculator if it says to round. Okay, now in our next video, we're going to see why radian measure is so useful. Catch you later.